Thank you. Our next growth company is pioneering a field of software development dubbed chaos engineering. Gremlin's failure as a service finds weaknesses in your system before they cause problems. CEO and co-founder who previously worked at Amazon and Netflix, Kolton Andrus, is going to discuss lessons from his experience of breaking things on purpose and why it's our responsibility to build a much more reliable internet.
It's 2 a.m. My wife and my 5 children are sleeping peacefully, as was I before my pager goes off. I jump up, I run downstairs, I log into my computer. Amazon is broken. I join a conference bridge with 30 other engineers, frantically trying to diagnose what happened and restore it as quickly as possible. Today, I'm call leader. It's my responsibility to manage this chaos. It's my job to fix this, whatever it takes. In this case, there were several things that went wrong, as is often the case in complex outages. Failures is a constant in our system. It takes us 45 minutes to resolve this issue, and during that time, Amazon loses $1 million in revenue. This is the world that I grew up in as an engineer, living at Amazon, preparing for these types of failures. In the e-commerce space, we're familiar with this. Days such as Black Friday or Cyber Monday are days of trepidation, days in which we prepare months in advance to ensure that they go smoothly. A day that anything that can go wrong will go wrong. And these outages, when they happen, are quite expensive to these companies, where they're losing hundreds of thousands to millions of dollars during an outage. On the consumer side, they're inconvenient, but we can get by. If a website fails, they're often thrusting us into the arms of their competitors, and people will go and find other ways to shop and get what they need. But this is an example of inconvenient failures. What about the more critical failures? As all of our systems move toward becoming online systems, as all of our businesses rely on the internet and the ability to interact with our customers on near instantaneous feed, there are worse things that could happen than Amazon breaking. The financial industry, for one, is a set of critical failures, things that impact our everyday lives. In this world, a world where dollars and cents mostly exist in a digital realm, what happens when failure occurs? We've seen examples in headlines recently of people being unable to withdraw money from ATMs. Can you imagine receiving a letter in the mail that tells you that your home was foreclosed on after diligently making your payments? And what we see here is that this is only going to get worse before it gets better. What happens when online government is a service that you rely on? You don't like going to the DMV or dealing with that process today? What does it look like if their website's down? What happens as our infrastructure, our healthcare, all of our systems move in this direction? There's one in particular I want to speak about. It's been top of mind to me recently. As someone that travels often, I spend a lot of time on planes. And in the past, these types of failures have been in the category of being inconvenient. A delay in being able to schedule, a flight not taking off on time. But what we've seen with the 737 MAX debacle is that it can be much more serious than this. This failure is common. This failure exists much in the same way as failures exist in our other chaotic systems. It's one part social, the people that operate it. It's one part economic, the business that makes decisions to try to maximize their profitability while minimizing the work that they do. In this case, it's one part software, and the malfunctioning software contributed to what has become a tragedy. And so this is the concern. When lives are on the line, it becomes a lot more than an inconvenience or a criticality. It becomes of the utmost importance to ensure our systems work well. So I want to share with you some of what I've learned operating these chaotic systems. Let me take a step back. Let me unveil the curtain and show you a little bit what a life of an engineer looks like at these companies. What are we looking at here? Well, it's complicated. It's chaotic. Each of these is a host, a server, a database. These lines are communication that occur between them. And if you're having a hard time making sense of it, we engineers feel the same way. It's very difficult to look at a picture like this and know what's going to happen, know what's going to go wrong. In the old world, our systems were a bit more straightforward. They were a little bit simpler. And we were able to, one person or one team could hold it all in their head. We could think through all the things that could go wrong, and we could brute force testing them to ensure that the system behaved the way that we wanted. Those systems were changing seldomly, often quarterly or annually. Let's contrast that with today's world. This type of system is different day to day. Code is being deployed on the order of hours or minutes. And so the system we tested yesterday is not the system we're operating today. Additionally, any combination of two of these things could result in a failure or side effects that we might not predict. And so were we to test every combination of failure in this space, the sun would burn out before we complete it. That's how complicated it is. Now, this system reminds me a bit of another system. This isn't the picture of a galaxy. This is the internet. Arguably one of humanity's most complex systems. A system that has some degree of chaos, some degree of failure lurking at all times. So how can we tackle this kind of a complex environment? How can we get in front of it? How can we ensure that we as engineers are building reliable software and that the people that rely on us can trust that we've done everything possible? This complexity, this chaos has given birth to a new discipline, that of chaos engineering. Chaos engineering is the concept that we want to purposely cause this type of failure in a safe and in a controlled manner to uncover the side effects, to learn how the system will respond, to find the types of things that would result in disaster, that would result in outages before they occur. This isn't a chaotic process, and we're not randomly breaking things. We're applying the discipline of engineering to tame the chaos within our systems. We would like nothing more than a boring system that did exactly what it should. And so we take this approach to better understand it, to better prepare. When I'm home for the holidays, when I'm speaking with my family, I find that the vaccine analogy is an easy way to convey this process. Now, if we went back 200 years and I asked you if I could inject you with this disease, you might tell me no. You might not be okay with that. But there's evidence that supports that vaccines help us to build immunities. They help our bodies to be able to respond to foreign agents. It doesn't mean that foreign agent may not ever arise again, but when it does, the body has learned how to combat it and is able to quickly neutralize that threat. The same concept applies in our distributed systems. By testing for the types of failure that can occur, by seeing the side effects, we can help our software to heal where possible. We can help our teams to understand how to respond to these types of incidents. And ultimately, we can build more robust, resilient systems as a result. There's another analogy that I find to be quite apt in this space as well. Who's grown up participating in fire drills? Everyone? Who didn't go outside during the fire drill yesterday? Yeah. But there's a good reason that we run fire drills, and that is if an emergency strikes, that's not the time to panic. It's not the time to run around with our hair on fire. It's the time for us to calmly and safely respond to the issue at hand. Now, this, again, applies in the way we build and operate our systems. As an engineer, the on-call training that I've received essentially amounts to, here's your pager. Good luck. You're smart. You'll figure it out. Imagine instead a world where we give our teams and our companies an opportunity to practice. Because this failure will occur. It's not a question of when. It's not a question of if, but when. And so we want, when this failure strikes, when that urgent moment arrives at 2 a.m, for teams to be able to calmly respond, to think about what could have happened, to be able to professionally handle and resolve that incident so that customers and users aren't put in danger and are able to go about their business, live their lives. And so as we as a society continue to rely on these systems, as our healthcare, our infrastructure, our government, autonomous vehicles, drones, everything that is exciting and is coming, and we are excited for it, we have to also prepare. We have a responsibility to build resilient, robust systems that can withstand the turbulence of our production environments. We have to be able to safeguard our customer experience and ensure that whenever possible, we're operating systems as safely and as effectively as possible. And so I hope that you will think about the types of failure that could occur in your life, in your system. Think of ways you could run experiments to uncover that, to suss